My name is Casey Langdon, and I am an assistant professor in the Department of Pediatrics in the Medical University of South Carolina, and I'm also a member of the Hollings Cancer Center. My laboratory studies fusion transcription factor-driven pediatric sarcomas. We're especially interested in tumors such as Ewing sarcoma, which is the second most common pediatric bone cancer. Ewing sarcoma is driven by this fusion transcription factor called EWSR1 Fly1. EWSR Fly1 is very difficult to target, so we need to find other ways that we could potentially find new drugs to attack this type of tumor. And one of the things that we found is that the PI3 kinase signaling cascade, which is shown to be upregulated across lots of other types of human cancers, is even further upregulated in Ewing sarcomas. Thankfully, there's a lot of different drugs that have been developed that could target this pathway. We found that although this pathway is highly upregulated, not every single cell line that we've looked at has this pathway upregulated in the exact same way. And one of the things that we found that correlated with this expression, correlated with this activity, is the loss of the tumor suppressor protein called PTEN. And PTEN is a negative regulator of this PI3 kinase signaling cascade. We've shown that not only do patients that have low tumor gene expression of PTEN do significantly worse, but cell lines that have loss of PTEN are more sensitive to this inhibitor of a protein called AKT, which is a part of this PI3K signaling cascade. Now, one thing we do know is that monotherapy is not going to be enough for these patients. So one of the things that we're trying to do now is to find targeted combination therapies for these patients. And one of the things that we're interested in is finding ways that we can reactivate this pathway to create synthetic lethal interactions. And one of those drugs that we think may actually be maybe synergizing really well with AKT inhibitors is an inhibitors of this process called nuclear protein export. And by blocking nuclear protein export with this exportin 1 inhibitor called selinexor, which is also FDA approved, we can actually reactivate the PI3 kinase signaling cascade, making these tumors more reliant upon this cascade. And one of the things now that we've been able to show is that whenever you combine AKT inhibitors with XPO1 inhibitors, you actually get a synergistic interaction and cause these tumors to even to melt away, really, even in xenografted Ewing sarcoma cell lines. One of the interesting things that we've also found is not only is this really synergistic in Ewing sarcomas, but other pediatric sarcomas driven by fusion transcription factors, such as desmoplastic small round cell tumors and fusion-positive rhabdomyosarcomas, which gives us an opportunity to really kind of expand upon if we were able to move this into clinical trials, where if any pediatric sarcoma patient that has a chimeric transcription factor may be able to be sensitive to this combination. Thank you for your time. I look forward to talking to you more at AACR in April. My poster presentation will be on Sunday, and I look forward to seeing you there.